Okay, so let's continue on discussing more on Bohr setup model. Okay, so various orbits can be n equals to 1, 2, n equals to 3. This is obviously the ground state. Okay, and this is, then after moving on, these are excited states. For exciteds we use star symbol. Okay, so we can write that for any n, we can write that mvr will be equal to nh upon 2 pi, where mvr is the angular momentum, which is quantized, and this is quantized actually. Okay, so just remember mvr equals to nh upon 2 pi. Okay, so where obviously n varies from 1 to 3 and so on. We can write that electron revolves only in those orbits whose angular momentum is quantized, or in other words, whose angular momentum are in simple multiples of h upon 2 pi. So electrons revolve only in those orbits whose angular momentum is quantized, or in other words, simple multiples of h upon 2 pi. Okay, so we have again mv square upon r can be equal to kze square upon r square, which is simply I am mapping the centripetal force with the force, electrostatic force. Okay, so this is the centripetal force. I am simply mapping the centripetal force with the electrostatic force. Okay, and q1 would be rather, we can just define q as, means it is generally k q1 q2 upon r square, where q are the electric charges on the two charges which are interacting with each other. So in this case I am writing both the charges present on electron and proton as E. So q1 and q2 in both the cases would be E, hence I am writing k z e square. Okay, because the charge on electron and proton would be, the numeric value would be the same, but only their difference is in the positive and negative sign. Okay, so we'll take the mod of it, and I'm directly writing kze square upon r square. Okay, so now we have got two equations. One is obviously we have mvr equals to nh upon 2 pi, this was the first one, and second one we have is mv square upon r is kze square upon r square. Okay, so this can be rewritten as mv square r equals to kze square. So from both the equation we can get velocity as 2 pi k z e square upon nh, and r as n square h square upon 4 pi square m k z e square. Okay, so now putting all the constants in velocity, constants like kz, 2 pi k n, 2 pi k h, okay, so n e square, so we'll be getting velocity as 2.18 into 10 raised to the power 6 multiplied by Z over N meter per second. Okay, just remember this. And secondly, we'll get R as 0.529 N square by C angstrom. Okay, now we can derive easily the kinetic energy of electron. So that would be half kZe square upon R. Okay, and potential energy of the electron, this would be minus kZe square upon R. Okay, and remember the fact that potential energy is twice negative than kinetic energy. Okay, and the total energy of atom is then would be kinetic energy of electron plus potential energy of electron. Okay, as we are not, as the neutrons and protons are at rest, so we will not be taking those facts into consideration. So kinetic energy is nothing but half kZe square upon R, and potential energy is nothing but minus kZe square upon R. So the total energy of the atom would come out to be half kZe square upon R, rather minus. Okay, so in other words, we can say that potential energy is twice total energy, and second thing we can tell is kinetic energy is negative of total energy. Okay, so with this we come to an end of this lecture. In the next lecture we'll be talking of total energy with respect to hydrogen atom. So before ending, just let me write the total energy. Total energy would be, so after you derive all the, means if you put the value of all the constants here, you will get total energy as minus 13.6 Z square upon N square, which is in electron volt per atom. So just remember this form also. So if you remember this, you will be able to calculate potential energy, kinetic energy and things like that. Okay, so we'll meet in the next lecture.